Welcome to the lecture series. In this lecture series, we are going to discuss about the DBSCAN, that is density-based spatial clustering, and this comes under the clustering, that is unsupervised learning technique. So in the previous lecture, we have discussed about the K-means clustering. Now we are going to discuss about the clustering techniques. So it comes under the unsupervised learning techniques, that is grouping of the similar data points depending upon their characteristics, features, etc. And it has a maximum intra-clustering similarity and minimizes the inter-cluster similarity. And importance in the data analysis, where this clustering occurs is in data analysis, whatever the field it may be. Once we have to go for data analysis, we can use this clustering technique like pattern recognition, data compression, anomaly detection, decision making support. So types, we have density based DB scanning and hierarchical based, partitioning based, etc. So coming to the DB scan, it is a density based clustering algorithm. It groups the points together in a closed pack, that is it uses a circle type. So it comes under the grouping of spherical. So key characteristics is it identifies the clusters of an arbitrary shape, and it robust to the outliers and noise, and it requires two parameters, that is epsilon and min points. So two main points is this epsilon EPS and this min points. So core points, we have types like core points. It is nothing but the points with at least min points neighbors. So core point is nothing but it should have at least the minimum points near. So if I'm mentioning that minimum points is equal to 3, that core point should have the minimum 3 min points near to it. So if I'm selecting this yellow as a core point, you see I have given minimum points is equal to 3. So this should have 3 minimum points nearer to it. So 1, 2 and this is 3. So it has 3 minimum points around it. So this yellow point can be called as a core point. Border point is nothing but points reachable from the core point. So if the point is reachable from the core point, it may be called as a border point. And noise point, points that are not belonging to any cluster. So it is scattered from here. So these are the noise points. So core points is it has at least min points as neighbors, and from the center of the clusters it forms as a center of the clusters within the distance epsilon of the each other. So it forms the center, and the distance of epsilon it forms the clustering. So core point is your main point, and it is the foundation of the cluster. So once if I am fitting the core point, I will choose a radius and I start to draw a circle around it. So it forms a grouping. More border points is not the core point themselves within the, but it should be within your border point, border line. Noise points is it is neither the border points or core points. Identify the outliers. So it is outside your border, outside your boundary, and not part of any clusters. And coming to the working condition, here you can see first we initialize the process and check for the neighborhood, evaluate the point density. So minimum points I'm going to specify. For example, if the minimum points is equal to 5 means I should choose a point which has at least 5 points around it. So depending upon the density, I'm going to choose the core point and neighbor points. And I'm going to classify it, whether it is a border point, a core point, a noise point. I have to classify the points, and I have to choose the radius and expands the cluster, and I have to repeat for all the points, and finally it forms a cluster and avoids the noise points. And coming to the epsilon, it is the neighborhood radius around a point. So larger epsilon means the cluster is large. So radius is large means the clustering will be also large, right? Next, if it is too small means cluster merges. So it have to take care of that epsilon. And minimum points is nothing but required to form a dense region. And if a higher minimum points means more stringent clustering, and if common practice of 4 or higher, so we can go for higher minimum points so that we can choose the correct core points. And parameter selection tips is use k distance plot to find optimal epsilons, and select the min points based on the domain knowledge not in a random manner, and try multiple parameter combinations, consider data density variations. And advantages, yes, it forms an arbitrary shape. There is no non-spherical clustering. It can be looking like spherical, but it is a non-spherical clusters. Noise handling and parameter efficiencies. And limitations, it is parameter sensitive, varying distance clusters, computation complexity, and border point ambiguity, etc. And here you can see for the k-means parameters, you will be seeing the border line like this. Yes, but here if you form the DBSCAN, depending upon the density, it classifies into two different circles. So these are the difference between the k-means and DBSCAN. In the next lecture series, we will be discussing about the support vector missions and their types and their working process. Thank you.